Hi, I'm going to make a quick video here to talk about this ring of 10 hexacontahedra. I didn't realize that they were half hexacontahedra, which I could see how they would share, because if you made it out of the blocks, if you physically made it, it would work. Okay, so let's look at what I did. I actually made full hexacontahedra. So it kind of works both ways, but if we'll look at that side again, look at this here, we'll see that I'm having a hard time steering. Okay, right there. If you look at that spot there, you can see that the way they join, it's really part of a neat thing. It's the rhombic dodecahedron is what's going on there. So anyway, so I have this 3D ring of 10 full hexacontahedra, and that's where they mesh together. The overlap isn't perfect in the way that I built it, but they do look the same from top view. That's what's so odd about it. Okay, so let me go to another shape here. Okay, this here was an attempt to use the same hexacontahedron, the same rhombohedron to make full hexacontahedra. You can see they jam together. What's fun is that the little difference right here, right in here, is a thin rhombic hexahedron. So it can be filled in, so to speak. So it's just a neat deal on its own. But yeah, they're not full. This one uses full rhombs. That's how the hexahedra would join together. This is kind of like, I'm going to keep making this video. It's going to take some time, but I'm going to explain this here. Let's see if I can make this quickly enough. Maybe I can. I have to get the right size length here. And yeah, it's kind of interesting that let's just say there was a disagreement, which is fine. I understand now what was going on. I'm having a really hard time with this. I'm not sure why. It must be the perspective of it. Anyway, I'm going to make a rhombic dodecahedron out of the fat. It's made of 2 fat and 2 thin rhombi, but in this case, I'm going to show basically 4 fat intersecting, which they can do because they can come from either side to make this rhombic dodecahedron. Okay, bear with me, it's getting there. And this kind of shows where I've kind of been, going after the guts, let's say, of the difference. If let's just isolate real quickly a couple hexacontahedra, rhombohedra here, so we have an idea. I do get confused, I'll tell you that much. Alright, that's what I want, this line here, this line here. What I'm trying to show is how they intersect and how that volume can be accounted for. And it's very close, once again, the overlap, but it's not the same. So, boy, I'm just kind of fudging it here. I could have had this made ahead of time. I'm going to pause and get some work done here. Okay, so basically I have a rhombic dodecahedron made out of the golden rhombus, and I've just made 2 of the fat rhombohedra. I show them coming from 2 different directions, but we do know that when they emanate out, they come from off of the same point, such as this. And so I'm just trying to show that there's an intersection there, obviously. And then there's also a void in here on either side. And then there's this void. Well, I should probably take this panel off. And I've actually got that kind of dissected into T module, or pardon me, E module units. It's actually 32 units. And I don't want to get into the math right now, but it's just the proof that why we were disagreeing, even though there's no need to be.